We've got, for our first one, we've got this factoring problem. Asks us to factor. So what are we going to do? How do we start that? How do we start this? Whenever we see the word factor, that's what we want to think about. Our most common tools for factoring, which are our X and our box. Or it could be that we do the factoring by grouping, where I break it up into pairs like this. We're trying to get it to be where they're multiplied together. It could be that we do our factoring by grouping, where we do it like this. But in this case, since it's an X squared, we're going to use our X in box. Or we can do the X and factoring by grouping, either way. We're taking our A times C at the top, our 1 times 15, so we've got 15 at the top. Our B goes on the bottom. Is there a pair of numbers that multiplies to make 15 and adds to make 8? 3 and 5. So we know if I use a 3 and a 5, we can fully factor this. So when we fill in the box, I'm just going to fill in all the pieces. That's when we get our X squared from the equation and our 15 from the equation. And then our 3x and our 5x. What do we get as factors here? What are we going to get when we pull those columns and rows? Say it again. Yeah, we get a 5 here, which is also going to give us an x here. So our first factor is going to be just an x plus 5. What's our other factor going to be? What's going to go up here? X and what? 3. Yep. Because that's what's shared between my 3x and my 15. I can take a 3 out. So our factored form for the or for our quadratic up there is this guy. It's set equal to 0. So if we wanted to write it set equal to 0, that would be totally valid. We were not asked to solve it. We were not asked to get all the way down to roots, so that would be where we could stop. They asked us just to factor it. Okay, questions on that one? Okay. The one on the top right, we've got kind of a whole story up here. But we've got a commercial for pizza that gives you a code for 40% off the order. And you have a coupon for 10% off. If your order is $64, we want to know what it would cost after the discount. So how do I figure out what my 40% off coupon and my 10% off coupon are going to do to my $64? If it was $40 off and $10 off, we could do that. But since it's percentages, it's actually based off of whatever the price is at that exact moment. So I can't just make it be 50% off. I'd love it if we could. But then if you get a 50% off coupon and another 50% coupon, it's a free item. It doesn't quite work. What's up, kid? Yeah. Good. Eyes on that one. So if I take my $64, my total bill, and I want to take 40% off, I could multiply it by 0.4, and that'll give me, or like 0.40 if it helps us to see it, where I take my percent, write it as a decimal. That would give me what my discount is. Or you could be, as I say, like Kaden noticed for us, we could say, because this would be, we would then need to take this away. Take away from total. So this one will have more work for us to do, but it's a little less in the setup process. Or I could take my $64 and multiply it by what's left over after I take away 40%, which would be 0.60. So if we do our $64 times 0.4, and we type that in a calculator, what we get is 25.6. So for the 40% off coupon, I would take away $25.60. So after this coupon, we would be paying $38.40 because that's giving us our discount. Whereas if I do it the other way around and I take our 64 times our 0.6, we get directly to that 38.40. So it doesn't really matter if you do it as this is my coupon that I then need to take away because this is how much I'm going to save. Or if you go, this is what's left for me to pay, we should wind up at that $38.40. So it gives me my 40% off coupon. To do the 10% off coupon, it's a very same vibe. I can either calculate my discount, so I could take my 38.4 times our 0.1, our 10% off coupon, where we would take off another $3.84. So our $38.40 minus $3.84 would give us a total of $34.56. Or similarly, as we did on the first one, I could take this $38.40 times how much we're going to pay. We're going to pay 90% of what's left, 0.9, and $38.40 times 0.9, and we get exactly that, 34.56. So whichever way you go through it, we get to the same cost. Whether we do it as I find my discount and I'm going to take it away, find my discount, take it away. Or we go, what's left over is what I'm going to pay. What's left over is what I'm going to pay. Either way is fine. It got us to the same answer of $34.56, which is not exactly what it would be if I just had 50% off. So if I had 50% off of 64, it would be $32. So even though I had a 40% off and a 10% off, because they're both based off of percents, it didn't quite get me all the way up there since they stack on each other. So the other option with that is to combine those together where we have 0.4 times 0.1 times our total and smush them together that way. But that one's a little bit riskier. So doing it in 2 steps is probably a little bit easier. Okay, so that one's a little weird and probably something we haven't done since like 4th, 5th grade. To do percentages, stacked in percentages. Questions on that one? Okay. So we've got our last one up here on the bell work. True or false? 31/9 is the exact same thing as 3.4. So are they exactly the same? No. Then why did like half of you tell me they were exactly the same on the chapter test? And a lot of you simplified 31/9 to be 3.4. This is the same thing as 3.4 repeating. If you did that, you'd be fine. But this is not the same thing. That's 34/10 or 3 4/10. It is not the same as 31/9. So these are not the same. This is false. Do not round unless we tell you to round. You can write things as decimals if you write them exactly as decimals. Do not just round randomly. This is not willy-nilly round for everybody. 31/9 is not the exact same thing as 3/4. Right? Okay. Questions on the bell work? Okie dokie. We're going to have a few more of those SAT practice questions because we have SAT coming up on March the 6th, I believe. So here is our next. I definitely gave myself a better picture than that. Oh, no, I didn't. That's not what I did. Okay, never mind. So we've got here a scatter plot with a relationship between two variables, x and y. So we know our x's are down here, our y's are over here. If we didn't remember, those pieces are labeled for us. And a line of best fit is shown. So they're asking us which of the following is the closest. So it might not be right on, but what is the closest when x is 25? So when x is 25, what do we think the y value might be? Yeah, so we find our 25, which is going to be right here between 26 and 24. We're going to follow it up here. We've got this dot right on 8, but our line's actually just above it. Oh, that is way too skinny. Hang on, let me make that line thicker. So we're looking at, not thicker. Looking at this line right here. There we go. Now we can see it. So there's a dot right at 8, but I'm not looking at the dot actually. I'm actually trying to look up here at the line. So our line is going to be right over here somewhere. So we expect this to be between 8 and 9, maybe closer to 9, because we want the point that's on the line right about here. So which of these values down here, A, B, C, or D, is closest to what we expect the line's value to be there? I would say 9.1. That one's a little tricksy because it has that dot right around the 8.2 mark, but the line is actually quite a bit above it. I would expect the value here to be something much closer to like 8.9. So 9.1 would be closer because this guy is closer than something like 8.2, which would be right about where this dot is. That is my expected answer for this one. I doubt they would have it that close. Usually it would be that 8.2 would be farther away. This is kind of deceptively close. Those are obnoxiously, annoyingly close. But that would be my expected value of it. So we don't necessarily have to find everything, but when they give you a line and they ask you to predict about the line, you can ignore every single point that's here. You are looking at the line. You are not looking at the points. The scatter points are just there so you can see where the line came from. You are looking at the line. The line is what you want. The line is what we use to predict. The dots helped us make the line, but the line is what we use to predict. Okay, so when we have scatter plots and a line, look at the line. The line's what we want. Questions on this guy? Okie dokie. So what we're going to do now is we are going to look at our next section in the book. This is a very, very short section because chapter 6 actually got divided across the 2 semesters. So we're going to be doing the second half of chapter 6. So this is only going to be like a week and a half. Like this is a very short chapter. So we're going to be working with operations on functions. And we did a little bit of this last semester. And I have a printout of this little table if you'd like to have it. If you're not familiar with this notation where we have like the f plus g of x, f minus g of x, this kind of stuff, this table might be really helpful. If you understand what those are saying, don't worry about it. You don't need to have it. I made it up so everyone can have one, but like this is, we're going to work with these enough. You're going to figure it out. These are not super duper complicated. But we're going to be doing some operations on functions today. So what we're going to do is we're going to give you 2 pieces and we're going to add them, we're going to subtract them, we're going to multiply them, we're going to divide them. We've done all these pieces before, so this might have been a minute. The one kind of funky thing in here, and the one thing we're going to write that's a little bit weird, that we're not going to go super duper into detail, is on our division, we have this little extra chunk here. Because the one thing we're not allowed to do when we have things in fractions is we can't divide by 0. It gives us something undefined. So what we'll do for that is we'll just say that our denominator is not allowed to be 0. And that's just about what we're going to do with that. We're not going to have a ton of like long division and stuff that we do here. We're, for the most part, going to save that for when we get into that chapter later. But we're going to work with these pieces. So if it says, and the way we read this is we say if f plus g of x, so f plus g of x. That's how I would say it. X plus g of x. Is the same as saying, well, I'm going to take f of x, and we're going to add g of x. So if it says f minus g of x, it means we're going to take f of x, and we're going to subtract g of x. If it has f times g of x, or it might say It might not have the dot in there. It might just say fg of x. It means the exact same thing. F of x times g of x. F of x dot g of x. It might have f of x star g of x. Those things all mean multiply. And we could have f over g of x like it has on this bottom one. Or sometimes we're going to see f, and then we'll see our division symbol, f divided by g of x. And it means the same thing. We're going to put f of x in our numerator, g of x in our denominator, and our denominator is not allowed to equal 0. So we're going to work with this with a couple of equations, trying to build these pieces together and see what's going to happen when we play with these functions. So what we're going to do is I'm going to give you two functions. I'm going to give you an f of x, which is 2x, and I'm going to give you a g of x, I got it right here, which is an x plus 2, and we're going to do an f plus x, or an f plus g of x. We're going to do an f minus g of x. We're going to do an f times g of x, and we're going to do an f divided by g of x. So we're going to do all 4 of those operations with these 2 pieces. So we're going to use these same 2 pieces for all 4 operations. So when we have f of x, which is our 2x here, and our g of x, I'm going to color code stuff just to make things easier. So my f of x is in my purple and my g of x is in green. So when it says something like f plus g of x, that's what this first one says. What that means we're supposed to do is we're supposed to take our f of x and we're going to add our g of x. So think of it like a big giant substitution problem. So wherever we have f of x, I can put in this chunk. That's what f of x equals. So we're going to put our 2x. And we're going to add that to whatever our g of x equals. Well, our g of x equals this x plus 2. X plus 2. And you're going to notice whenever I do this, I'm going to substitute them in parentheses. In addition, it's a little over the top. But for all the other ones, it's really, really helpful. So I'm just going to be in the habit of always substituting things in parentheses. And if they're not doing any jobs, I can get rid of them. But I don't want to make that assumption right off the bat. So on this one, my parentheses aren't actually doing anything. So this is the exact same thing as if I had 2x plus x plus 2, which is going to simplify. 2x plus x plus 2 gives me 3x plus 2. So f plus g of x got to 3x plus 2. So we're going to substitute pieces in, and then we're going to simplify. So my f of x is my 3x plus 2. When we look at something like our f minus g of x on the next one, it's doing the very same thing. I'm going to take my f of x, and we're going to subtract our g of x. And this is going to be the first place where we see that these parentheses are actually very important, because we're going to substitute in our 2x, and then we need to subtract everything in our g of x, that x plus 2. When I have a quantity that's being subtracted like this, what do I need to do with my minus sign here? Distribute it. I'm going to need to bring this minus sign into both pieces afterwards. That's going to make it so that we can actually do this subtraction. So my 2x at the beginning isn't going to change, but then we're going to have minus x and minus 2. 2x minus x minus 2. 2x minus x gives me just 1x minus 2. And this is what we get for our f minus g of x. 1x minus 2. You can also just put x minus 2. That's totally fine. They mean exactly the same thing. Questions on either of those two? Because we've done those pieces before, but it's been a minute, so it's nice to go through them again a little bit slower. We've done this next piece before too, but it's good for us to remember because we're going to use these all again in the upcoming days. We're going to take our f of x and we're going to times our g of x. So f times g of x is the same as having f of x times g of x. They just word it differently because mathematicians are extra. So again, this is going to be where our parentheses come in really important because now we have our 2x times the entirety thing of our x plus 2. And when we're multiplying these two pieces together, what does that mean I need to do with my 2x? How do we multiply those together? That is really small. This is a distributing kind of problem. So my 2x, we're going to have times our x. And my 2x, we're going to need to do times the 2. So we need to distribute this. So when we multiply those together, we're going to have our 2x times x gives me 2x squared. I'm going to make that 2 just a little bit bigger. I feel like I'm writing very small. My 2x squared. And then we have our 2x times 2, which gives us 4x. I don't have anything I can combine together. We don't have any more like terms to work with here. So this is what we get for our f times g of x. And then our last piece on our very first set of operations, we're going to have our f divided by g. That's the same thing as having f of x over g of x. So we're going to set this up as a division. We're going to put my f of x, which was my 2x, over my g of x, my x plus 2. And since this is not a monomial, if this was a monomial, we could simplify it a little bit. We're not going to do that. If this is something that looks like this, we're just going to kind of leave it be unless we specifically ask you for more. The only other thing really we're going to include is that we know that this guy shouldn't be 0. My g of x cannot equal 0. So my x plus 2 cannot equal 0. That's the only other thing you're going to have on there. You can absolutely finish that, solving that out, and figure out what x doesn't need to be, but if you just write it like this, I am entirely happy with it. We are not doing too much with the division. Mostly we're doing this so that we finish out doing all 4 pieces, and when we get to the chapter that has a lot of x's in the denominator, we don't get absolutely freaked out. So that's where we're going to stop for the dividing things. We're not doing a whole lot with it. We're just going to write it like this. And we will look more into what these things all mean when we get into the chapter that looks at these guys more particularly. So there's our first set of these. Questions on this one? Because I know we've done these with linear equations before like this, where we've had these kind of setups. So not everything we're going to do is going to be 2 lines like this. Sometimes we're going to give you wilder polynomials. Oh, snap, what? So we're going to do those same 4 operations. I'm just going to give us some new f of x and g of x's. So now we're going to have f of x that's x squared plus 3x plus 1. And we're going to have our g of x that's 2x squared minus 5. Okay. And we're doing those same operations. We're going to do f plus g of x, we're going to do f minus g of x, f times g of x, and f divided by g of x. So when we're looking at our f plus g of x, that's our f of x plus the g of x. I made my pen a little bit thicker so I couldn't I won't write a small this time. So when we do this, we're going to substitute these pieces in. I'm going to substitute in for f of x my x squared plus 3x plus 1, because that's what f of x equals. And then we're going to add that to our g of x, my 2x squared minus 5. Are you good, guys? On this one, we're just adding, so my parentheses aren't actually doing anything. We're just trying to combine some like terms here. So I'm going to have my x squared plus 2x squared to give me 3x squareds. My 3x doesn't have anybody to combine with, so we're just going to have our plus 3x. And I've got 1 plus negative 5, which gives me a minus 4. So my f plus g of x is going to be this thing right here. Questions on this? It's not really different when we have polynomials, but it feels weird. Questions on this one? It's possible, but unlikely. Yes, dear. Yes. I was like, it is possible that we would ask you to factor it, but honestly, I can't think of a situation in which we would need to. I'm not going to say never because I don't remember, but as of right now, I do not remember any times when I would have you add these together and then factor them. They go here. All right, same kind of vibe for our subtraction. We're going to take our f of x, and we're going to subtract our g of x. It is important what order these are in. F minus g of x does mean we're going to take f of x, then subtract g of x. If it said g minus f, we would just switch our order. But for the most part, we're going to give these to you in the f and then g situation, ordering just because we're trying to keep things consistent while we're figuring it out. So our x squared plus 3x plus 1, and then we're told to subtract our g of x, that 2x squared minus 5. So when we're subtracting, we need to be really, really careful because we actually need to distribute our minus sign here. So I'm going to do this one. I'm going to write a whole nother step in here because I'm going to write it without any sets of parentheses. So we're going to have our x squared plus 3x plus 1. And then we're going to have our minus 2x squared. That minus sign to the minus 5 becomes a plus 5. And then our last piece is to combine our like terms on this. So I've got my x squared minus 2x squared, which is going to leave us with a minus 1x squared. My 3x doesn't have anybody to combine with, so it's just going to come down, plus 3x. And then we've got a 1 plus 5, which gives us a plus 6. There we go. I'm not going to do that. I'm trying to make it so we could see where all these things are coming from. So this is our combined together total of our f minus g. Okay. Questions on that one? Those ones are a little bit bigger. All right, our next one, very similar vibe. We've got f times g. So this is when we take our f of x, and we're going to multiply it against our g of x. This one's going to be a little bit icky, but we can do this. We're going to take our x squared plus 3x plus 1, and we're going to multiply our 2x squared minus 5. This is when we're going to multiply things out. So I'm going to do the full set with the distribution and all that jazz. I have a lot of you that tried to do this whenever we do factoring by grouping, but this is when we're going to multiply. If I have parentheses smashed together here, we're going to multiply, trying to make this bigger. So we're going to have our x squared times our 2x squared, which is going to give me 2x to the fourth. And then I'm going to have my x squared times my minus 5 to get minus 5x squared. I'm going to have my 3x times my 2x squared, which is going to give us 6x cubed. And my 3x times my minus 5 gives me minus 15x. I've got my 1 times my 2x squared, so we've got my 2x squared. And I got my 1 times my minus 5, so we have minus 5. So I'm multiplying the whole thing out. We're going to get these to be without parentheses for our final answer. So then we need to combine some like terms here. And we're going to put it in standard form, meaning biggest to smallest. So my 2x to the fourth is our biggest piece here. So I've used this guy. The only cube I have is this guy here, so my 6x cubed comes next. I have two sets of x squared. They've got a minus 5x squared and a plus 2x squared. So it's going to leave us with a minus 3x squared. I've got a minus 15x and a minus 5. And I'm right on the edge. There we go, but we got it. There's nothing else we can combine together. There's no more simplifying we can do. So my f times g of x is going to look just like this. And again, for our division stuff, we're for the most part just going to set it up. We don't really have to do much dividing with it. But this is where we're going to take our f of x and put it over our g of x. So when we write these in the fraction, we're going to have our x squared plus 3x plus 1, and we're going to put that over the 2x squared minus 5. And the only other thing we're going to do it is we're going to write where we're going to have a problem here. If my 2x squared minus 5 cannot be equal to 0. This is how we're going to write these division problems, just like this. And if it helps you, you can put like a little semicolon right there. Or you can put a colon like this. Or you can put a little vertical bar. I tend more towards just like a semicolon. But I'm not super picky about what set of punctuation you have in between there. A period for all I care. Could just be a space for all I care. But what's important is we're setting up that f of x over g of x. And we're remembering that we cannot divide by 0. So the denominator cannot equal 0. Okay. Questions on these guys? Okay. So, I have another set, but honestly, I'm going to give you guys the homework, because I'd rather you guys work and ask questions, because I feel like you guys are 100% tuning me out right now. And that's okay. I get it. I also have a new thing that's been added by higher than my particular choices are allowed to make the choice of. There is going to be a Canvas assignment for us every week between now and SAT. So every week there's going to be a new Canvas assignment. So we apparently are now doing online homework for us. So that is also on top of homeworks. So I'm going to try and give you guys time during class to do it. They're not super long. They are almost entirely multiple choice. This is coming from higher up in the food chain, where they want you guys to really work on those SAT scores, because they've been kind of dropping the past few years. So there is, I'm just pulling it up to look at it. Yeah, it is almost entirely multiple choice. I think there's 2 questions that are not multiple choice. So it's just practice SAT questions. They are relatively based off of things we've done recently, so they're all things that you can do, but this is coming from district and higher, so we kind of have to do it. So it's up there. I will try and make sure I give you guys time in class to do them, but yeah, that's one of those things that I was informed of. However, that is not different, or that is different than our actual homework, which is this guy. There's only 2 homeworks in this section. So this is the first one. I'm gonna give you guys one more later this week, and our quiz for this is next week. I want to say it's like Wednesday. Yes, Wednesday. Oh yeah, sorry, I didn't even realize I didn't have booster boxes out. Let me try the booster boxes out to get these little people thingy in. 100%, I did not even realize I hadn't put those back out yet. Oh. There we go. I'm so big now. Find those boxes. I did not even notice that I didn't have those out, y'all. Okay, so you guys have some time. Also, I have the chapter test graded. If you want to see your chapter test, I can show it to you. You cannot keep them, but I'd be more than happy to show it to you if you are interested in seeing it. If not, that's totally okay, but I've got them here if you want them.